All right, well, thank you all very much. I thought the best way to get some attention would be to set this ominous black box right here. And I will explain what's in there in just a second. But again, my name's Twyman Clements, and I'm going to be talking about, I titled my talk, A Funny Thing Happened on the Way to Space, because I was the program manager for a satellite program that was launched in November. And I'm going to talk about that process and show the launches, which everybody wants to see, but some of the unintended consequences and some of the cool things that came out of that. So again, I'm Twyman Clements, and in perfect scheduling by the IdeaFestival, I am from Bardstown, Kentucky, which Kim just talked about. So that was great on their part. One other thing I wanted to show here with this picture is that I'm not as tired and haggard as I look in my photo that's shown everywhere. That when I sent that in, I wanted the rocket to be the center point of it. So this rocket behind me is what launched our satellite, along with 28 other satellites back in November, and you're going to see that guy take off. And there's actually a really cool story about that. The organization I work for is called Kentucky Space, and we had 3 satellites launch in less than 24 hours from 2 different continents on 2 different rockets. And those 2 rockets actually have an interesting history, which I'll share with you. So Kentucky Space is a nonprofit based out of Lexington. It's an umbrella organization that works with universities and for-profit, nonprofit institutions in the state to basically build an aerospace base for students. So I started as an undergrad student at the University of Kentucky. I went on to get my master's degree there. And we work, on these 2 projects, we work predominantly with the University of Kentucky and Morehead State University. And I've shown this picture on the right here is at Morehead State University. They have a world-class space science center, and you'll see actually a picture on the inside of that building where we built part of the satellite, but they also have a 21-meter radio dish where they can do space science, look at black holes, quasars, all these different things, but also communicate with our satellites when we put them in orbit. So one of the fun things about being here in Bowling Green is the first thing I worked on when I was a student at Kentucky Space was a high-altitude balloon. And these are these big weather balloons. They're about 8 foot in diameter, big latex balloon. You fill them with helium. You put sensors or whatever you want to put on them, and you launch them. So the first one we did was out of Bowling Green, Kentucky in 2008. It was the first thing I'd ever worked on. We launched it right out of the airport down here. It went up and landed about, I was on the landing team, so I was about 60 miles east of here in, I can't remember, I believe 88, Kentucky, at a truck stop with some antennas tracking it. What I later found out, which is consistent with balloon launches, is that it went the opposite way and landed 60 miles west of Bowling Green. But we do a lot of these high-altitude balloon launches, and this picture was taken with a regular Canon camera that you just buy at Walmart. We hacked it to take pictures, and this picture was taken at about 100,000 feet above the Earth. You can see, and what we usually do these is we do these with high schools. We teach them, we do some science classes with them, and then it culminates in a launch at a local park, and all the students get to work together. What we usually do is we usually put a camera looking down. We did one with the Girl Scouts of Eastern Kentucky. We put a camera looking down, and we let go of the balloon, and we usually have a competition to see which student is either seen or heard last as the balloon is going up to about 20 miles up. One of the interesting things about doing these balloons is when you launch them out of Lexington, they land in Eastern Kentucky. And I've mastered an art I call Appalachian diplomacy, because you have to show up, you have to find the landowner, you have to explain to them this crazy story about launching a balloon with cameras and stuff on it for this instance, the Girl Scouts, and then go back and hunt through their land after they give you permission to do so. And one of my favorite ones is we had one land up about 90 foot up in a tree, up in northeastern Kentucky, and I couldn't get it down. I was throwing a baseball with fishing line on it, trying to get it over to pull the balloon down, couldn't do it. The guy who I got to know there, the landowner, was a real interesting guy, and he didn't sleep a lot. So he calls me one day at about 1:30 in the morning, and he just calls me and he said, "Twyman, I cut down the tree, you can come get it." And so I had to drive back up there and find the cut tree he was going to use for firewood and extract our balloon. But the Girl Scouts got their experiment results and everything. But what I'm here to talk about are satellites. So we do balloons, but we also do satellites, and we even do some work on the International Space Station, but I'll get to that in a minute. But we build small satellites. So most people think of these big satellites that are the size of a school bus or bigger, multi-$100 million, billion-dollar programs. But we build small ones. And as an example, I have 4 satellites in this box right here. These are scale models And this is a scale model of KYSAT-2, which is the one that was launched in November. And it's what's called a CubeSat. The CubeSat standard was developed in 1999 out at Stanford University and Cal Poly, and it was designed for aerospace students to build and launch a satellite in 2 years. Now this is what our satellite looks like, and Brian talked about 3D printing. This one is completely 3D printed, but what happens is when ours is released from the rocket, it becomes a transformer and opens like this, and these are the solar panels, these are the antennas that are sticking out, and what this satellite is doing is it's orbiting the Earth right now, 380 miles up, moving around at 17,500 miles an hour, or 5 miles a second. And it's got a camera on there. And it's taking pictures of the Earth when it's over the northern hemisphere. And over the southern hemisphere, it's flipping around taking pictures of star fields to do some research. So you'll see this one. That one went up on the first rocket you saw. I've got a video of it. But these satellites, college students really started building these about 5 or 6 years ago. And now they've gotten into industry. And now people are using these small ones to do commercial ventures or do scientific research. And actually, this one behind me was built at Morehead State University and was looking at the remnant radiation of the Big Bang between the gamma and X-ray bands. So it was doing real science. So this picture behind me is from a company called Planet Labs in San Francisco. They are right now launching 28 satellites that are this size, this big, right here. They're launching 28 of these off the International Space Station. And those satellites are doing Earth imaging. So they're doing imaging of the Earth every 24 hours. They can pass any place on the planet within 24 hours and take an image of 3 to 5 meter resolution, maybe a little bit worse. But that way, it goes into another thing Brian said, which is big data. These little satellites are allowing you to gather data all around the Earth almost near instantaneously. So how we got here. So the first satellite we worked on was one called KYSAT-1, which is behind me. It was a 1U CubeSat, the size of the first one I showed you all. I'd worked on that when I was an undergrad, and another thing I'd learned about the launch business is we were the first selected on a NASA program called the Alana program, where they took educational satellites and they put them on rockets with climate satellites. Because usually when a rocket takes off, it has some excess capacity, so they can throw these little guys on there. Unfortunately, that one launched, and there was what they call in the launch business an anomaly, and that is now sitting at the bottom of the Antarctic Ocean. And that was the problem with the launch vehicle, not our satellite riding on there. But what was really unfortunate was the satellite that went down, which was a climate observing satellite. We'd worked on ours for about 2 years. That one had been worked on since before I was born. So people have been working on that satellite since the mid-'80s. So that was a difficult one for them to stomach, obviously. So this video, which I should start playing here. Well, when it gets going, this is a video from a group out of San Francisco, a different company called Skybox. And they are flying satellites that are about the size of a college refrigerator that are imaging the Earth as well. And this video is going to play. Okay. Well, what the video is showing is it's the first HD videos from space. So what they're doing is they're monitoring real-time the plumes of power plants, or they're monitoring traffic patterns in real time. And one thing that a company like this advertises is that they can tell Walmart how many cars were in their parking lot in North America on Black Friday. Stuff like this. Another thing they do is they look at oil tankers that are stationed off the coast of some of the major oil refineries to see if people are hedging their bets financially. So you can give up on it? Okay. So this picture behind me was taken at Morehead State University. And this is the clean room that where we built some of those satellites. So again, this is at Morehead State. People don't think that that's a hub of space activity, but it really is. We built KYSAT-2, 2 other satellites that I'll show you that are actually smaller than that one, and an Italian satellite that launched on a Russian vehicle later this year. Spent many late nights working in that. So KYSAT-2, again, it was Kentucky Space with Morehead State and the University of Kentucky, and that was our logo. That's the first thing you got to do, obviously. So then I wanted to show the iterations you make. And what you see here are our first prototype, machined aluminum. That's a 3D printed model you see there, and then you see the design iterations of the battery holder. And that's another, we talked about 3D printing. That technology allowed us to iterate within hours of designs. We can put something together, it doesn't look quite right, that's not going to be in spec, let's go to the next one. So it allowed us to really fail fast and cheap, which was really incredible. The other thing was, which is what they talked about earlier with Kickstarter, is that some of these technologies lower the barriers to entry. And 3D printing allowed us to do that. That first one, that green one, was the first prototype we made, which is basically two green sheets with batteries that we bought from a hobby store. And we just needed to get something on paper. We needed something that we could hold. So we printed that. It was not even close to what we wanted as a final product, but we could take that and then we could criticize, we could iterate, and we could keep going, which got us to that, which got us to the lower left-hand picture. So now we keep going. In that first picture you see with all those crazy wires and stuff, that was actually the flight model that's in space now. That's us building it up. So you can see it's got some of it, its power system, it's got its radio, it's got its onboard computer, it's got all these different things, and then all these wires sticking out. Now the picture right here, that's the camera that we flew. And the material that camera is in, we flew some 3D printed parts on the satellite itself. That material was actually used for Formula One racing. It's a group out of Italy, and they print these parts for Formula One cars, and we realized they would be perfect for our satellite. So we actually flew 10 parts on our satellite that were 3D printed. And in all honesty, if we started a program today, we'd probably print almost the whole thing. So these are the pictures in the clean room. You build a satellite in a clean room. You wear these bunny suits so that you don't get hair or dust on anything, because you can mess up your optics, you can mess up your electronics, all kinds of bad things. But a lot of these pictures you see here are kind of what I call our Apollo 13 moments. If anybody's seen that movie, there's of course, a lot of bad things, or in the middle of the movie, a lot of bad things happen. But the moment where they have to do the scrubber, they have to fit the round peg in a square hole scrubbers. So when you're building a satellite, you have a lot of those moments where something doesn't fit, or it's not communicating like you wanted it to, or something like that, and you basically have to sit there and look at each other and be like, how are we going to fix this? And we had dozens of those in that clean room working late at night. This one was actually at the University of Kentucky. But you can see us measuring really the final model of it in that clean room. And voila, that's the flight model. That's the model that is zipping around in space right now. We actually worked a pass last night in the hotel parking lot. It passed over Bowling Green, so we were able to capture its packets and make sure she was doing okay, and it's healthy. So we have CubeSats, but now we've even moved smaller, because a lot of the technologies that are driving the intelligence in your phone, the sensors in your phone, are the same things that are driving these satellites. So we launched three pocket cubes, and this is a pocket cube. There are 3 of these whizzing around the Earth right now as well that we're talking to. These don't have cameras on them like our first one, but still, it allows people to really, again, fail fast and cheap, which is kind of the key to innovation. So there were 3 of these built. They were put in an Italian satellite that was launched off a Russian rocket, and then once the Italian one was out, they released the pocket cubes, the smaller pocket cubes. And again, one of them was even called $50 sat, just to show how cheap, how inexpensive you can make these. But they have all the same systems as the big guys. They have solar panels, they have radios, they have onboard processing, they have batteries, they have thermal control, everything. So now we're going to get to the launches, and I guess we're not going to have any videos, are we? All right, we're going to try the videos. So this is just a picture. This is a picture of the one KWASat 2 went up on. And I'm going to show you both of these videos because everybody likes rocket videos, but I'm going to show you there's an interesting relationship between these 2 rockets. One note about this went up in Wallops Island, Virginia, which is an interesting area if anybody's been there. It's on the coast of, Atlantic coast of Virginia. It's got the horses, the Chincoteague horses there, and then there's a launch range. So this is our first one, I think. It's a very dark, our first one launched it, okay. So this one, all right, this is a different launch, but I'll talk about it. This one's out of Russia, and this is what's called a Dnepr launch vehicle, and this is what launched, this rocket, launching behind me, launched this guy. And you'll see it's a pretty inventive way that this rocket is launched, and I'll explain why here in a second. But basically what the Russian government does is they have these rockets sitting around, and they lease space on them to whoever wants to launch something into space. Now, it's interesting, though. These do not launch like you think most rockets that you see in America do, where they're on a launch pad, you light it, it goes, which you'll see ours go. This one gets shot out of the ground and then basically hovers in the air for a few seconds and then lights its engines and takes off. So this one had 32 satellites on it. And this one was launched 18 hours after our one out of Virginia. Okay, so we'll go to the next one. And this should be the Wallops Island launch, which should hopefully have sound. And one of those things, while that video is being brought up, I wanted to point out was in less than 18 hours, we had the one in Virginia, it had 29 satellites on it. We had the one in Russia, 18 hours later, that had 32 satellites on it. So we had that many satellites launched in less than 24 hours. And a stat that I brushed over earlier, between late November, that rush right there, and March 1st, there will be over 100 small satellites put into orbit through the launches I just showed you and the space station. And these all have sensors, they're doing optics, they're doing commercial imaging for like the video or the image I just showed. So they're doing all these different type of things, and they're basically just swarmed around the Earth taking all these images. So we
don't have that one, but we've got the Skybox one.
You have the Skybox one. Okay, we'll go to the first one then. So we'll roll with it. It's a cool video. Well, we have the music. There we go. Okay, so this is a video taken from a satellite. This is a 720 quality video. So they can watch mines, the rate of mining of different places. This one's in Australia. You can look at traffic. This one's in Las Vegas. And the cool thing is you really can't see it here in just a second, but they have one of Tokyo. This one's in Aleppo in Syria, looking at war. Now they have a cool one here in Tokyo, and you'll be able to see it because Tokyo has the highest buildings. But if you watch the tall buildings there, you can see them swaying because this satellite, again, is moving 5 miles a second above the Earth, but it's sitting there looking at one area. This one's Bangkok. So again, like I said, it goes all into this big data. Now you're able to sense all these different things that you weren't really able to do before and are impractical to do with aircraft right now. This one's with a plume that you can back out basically energy activity from the plumes that you see from power plants. That one's in Maryland. So there are 3 of those satellites up right now. They're working to, I believe, a constellation of maybe 9 to 12. I'm not quite sure. So, okay. And then we have the Virginia. You don't have the Virginia launch? Okay. Well, we can just go back to my slides. So we can tell the story of the interrelationship between those 2 rockets. Okay. We'll get to that one. Okay, so the top one is that one out of Virginia. That bottom one is that one out of Russia. You notice that one out of Russia came out pretty suspiciously. The reason is the top one is what's called a Minotaur rocket. In its previous life, it was called a Minuteman missile, which if anybody, or a Minuteman or a Peacekeeper missile, which anybody who's a Cold War buff will remember. The bottom one is what's called a Dnepr launch vehicle. In their previous lives, these 2 rockets had nukes on them that were pointed at one another. And now that that's over, they've taken the nukes off of them and now use them for satellite launches, which we thought was a very interesting thing, that both of these rockets, which again were pointed at one another, had satellites that were built in Kentucky and launched in less than a day from one another. So these are all the students that worked on the satellite. You can see that this was right after our launch. Like I said, our previous launch did not go so well, so we were so happy when that one took off. So one of the final things I wanted to show was we do a lot of work on the International Space Station, and people don't even know that's up there. And I wanted to show, this is actually a photo with the last time the International Space Station was attached. We're doing a medical experiment up there later this summer looking at regenerative medicine. Basically, whenever we're using planarian flatworms, we're cutting them up, and they use the gravity gradient to figure out what part of their body to regrow. But if you take gravity out of the equation, you scramble that signal. So we're trying to see what happens when we do that. All right, I've only got a minute left, so I wanted to show, this is my last photo. I love this photo. This is a picture of Saturn, obviously. It was taken by the Cassini spacecraft. And I call this the second team photo because we're all in this photo. Because if you look really close, there's the Earth, right in that speck right there. This picture was taken 750 million miles away from the sun. And you might have to Google this so you can actually see this speck, but we are right there under what would be that second ring. And I'm out of time. Thank you very much. You can look on our website for the video I was trying to show you. So thank you.